Hello viewers. So today we'll explore an important topic in differential calculus, that is parametric differentiation. Now before discussing this topic, let us have an introductory idea of what a parameter is. Instead of a function y equal to fx, say we have a function y equal to fx. Here x is called independent variable. This is called independent variable and this is called dependent variable. Clear? So y is a function of x. Now instead of a function y equal to fx defined explicitly in terms of the independent variable x, it is sometimes useful to define both x and y in terms of a third variable, say t, and this t is known as a parameter. This is known as a parameter. Okay? Now some relationships between two quantities are so complex that sometimes we need to introduce a third quantity in order to make the things easier and understandable. Clear? And by introducing this parameter t, we can handle the things, and this third quantity is called parameter. Now let us take an example to understand the meaning of parameter. Suppose we have the equation of a circle x square plus y square equal to 1 square, say 1, or we can write it is 1 square. Now if we express x as cos t and y equal to sin t, then obviously this equation 1 is satisfied. Clear? Why? Because it is x square plus y square is equal to cos square t plus sin square t equal to 1. This is due to the trigonometric identity cos square theta plus cos sin square theta equal to 1. And here one important thing is t lies between 0 and 2 pi. So what we have done here, we have expressed x as a function of t and similarly y as a function of t, and y is also a function of x. So let us express it like this. Say y is a function of x and x is a function of t, say x equal to gt, and y is a function of t as ht. Clear? Here this equation is the equation of a circle or a unit circle whose center is origin and radius is 1. So x equal to cos t and y is equal to sin t are known as the parametric equations of a circle. Clear? And this equation, that is x square plus y square equal to 1, is known as Cartesian equation of circle. Clear? So in Cartesian equation, the variables x and y are involved, and while in parametric equations x is expressed as a function of t, and similarly y is a function of t. Now let us also discuss the parametric equations of a parabola, and the vertex of this parabola is at origin, so its equation is rather the Cartesian equation is y square equal to 4ax. Now if we express x as a function of t and y as a function of t, we can express the parametric equations as x equal to at square and y is equal to 2at. And if we substitute these two values in this Cartesian equation, we can easily verify that these two equations satisfies this equation. So these are the parametric equations of a parabola y square equal to 4ax. Now let us come to the topic parametric differentiation. Now here, if we have y equal to fx, then we want to find the derivative of y with respect to x. That is the first derivative of y with respect to x. Now suppose instead of Cartesian equation, if we are given the parametric equation, these are the parametric equations, then how to find the parametric differentiation of y with respect to x, or we can say that how to find this derivative dy over dx. So in that case, what we will do, we will first differentiate x with respect to t, and we get g prime of t. Similarly, we differentiate this y with respect to t, and we get h prime of t. Now, in order to find this derivative dy over dx, will divide these two. That is, we'll write dy by dt over dx over dt, or we can say h prime of t over g prime of t. So this is the rule to find the derivative of y with respect to x when x is given as a function of t and y is also given as a function of t, where t is known as a parameter. So let us illustrate by taking some simple examples. Now let us take the example of this parabola. Suppose we are given x equal to at square and y equal to 2at. We have to find this derivative dy over dx. So what we will do, we will find dx over dt. So we will differentiate it, and we get the derivative of t square is 2t, so it is 2at. Similarly, dy over dt is equal to 2a. The derivative of t is 1. Here we have used the formula. The derivative of x raised to n is nx n minus 1. Now the derivative of y with respect to x is dy over dt over dx by dt, and dy by dt is 2a and dx by dt is 2at. So 2a get cancelled and we are left with 1 over t. So dy over dx is 1 over t. So this is the first derivative. Suppose in addition, we have to find the first derivative at t is equal to say 1. Then the required value of the derivative at t is equal to 1 is obtained by substituting t is equal to 1 in equation 1. So it is 1 over 1, that is 1. And in fact, this term represents the slope of the tangent to the curve, and here the curve is parabola. So slope of the tangent to the curve at t is equal to 1, and the slope is, this is the slope, and slope is 1. So m is 1. It means m is tan of theta. So theta is pi by 4. So it means at t equal to 1, the tangent to this parabola makes an angle of pi by 4 with the positive direction of x-axis. Clear?